Assalamualaikum warahmatullahi wabarakatuh and a very good morning. For today's session,
can you please give the QR code again? I just joined.
okay, never mind. I will share you during the intermittent class. All right.
Okay, thank you.
Okay. So, do you still remember the last class that we have learned? Please, anyone volunteer. What have we learned during our last class? Anything? Still remember?
Viscosity.
Pardon?
Viscosity.
Okay, good. So, anyone else other than viscosity? Is it we only learn viscosity? We have learned two types of viscosity, right? Kinematic and dynamic viscosity. All right. And any idea? Do we have any kind of... Okay. So just recap, what have we learned during our last class? Okay. So during our last class, we learned about the viscosity. All right. So we try to calculate the viscosity for the flow between two plates. Okay. So from here we use the equation sharing stress, which is tau equal to force over area, or equal to dynamic viscosity U over Y. And then we do the quiz. All right. From here, we calculate, we do the breakup session. Remember, I assigned 12 group to solve this kind of question. Right. So remember that in order to calculate the force required to drag a thin plate, we need two forces, the combination of two forces, all right? The top shearing stress, tau 1, and the bottom shearing stress, tau 2. Okay, from what you learn, once you get tau 1 and tau 2, convert into force by multiplying with area. And then you get force 1 and force 2 plus together. And then finally, you learn about vapor pressure, all right? This kind of topic will be used for the next session, okay? The vapor pressure is where the liquid vaporize and then the particle or the vapor exert the pressure to the surface of the liquid. Okay. So for today class, all right, we're gonna learn about hydrostatic. So have you ever heard about hydrostatic? Anyone? Do you know what is hydrostatic? Okay, what is hydrostatic?
Force exert by fluid on a surface or...
Okay. Basically, hydrostatic means hydro. What is hydro? Hydro. Hydro mean water. Okay. Static mean not moving. So that means this is the condition where water not moving. Okay. Wait, yeah. All right. So from here, hydro means water. All right. Here, static mean not moving. Have you took static before during your first semester? Anyone? This is static, anything not move. Okay, not moving. So hydrostatic condition if fluid velocity is 0. Okay, that means there is no motion, definitely there is no velocity. Very simple. No shear stress, just normal force from pressure. Okay, so what it means? For example, this is a fluid particle, okay, inside a beaker. Alright, and then we have a fluid particle. Alright, so since it is not moving, definitely there is no shearing stress. Shearing stress means it is moved in a tangential direction. Okay, so only normal force. So what is the force here? Alright, only normal. Normal means it is perpendicular to the surface. Okay, how it perpendicular? You can see here. 90 degree. It is 90 degree perpendicular. So when the fluid is static, that means it has no shear stress, no tau. Alright, this is tau. Pressure normal force exerted by a fluid per unit area. This is what we learn lah. The pressure, yeah. This is the pressure. The force coming from pressure. So absolute pressure, when we talk about pressure, normally we divide the pressure into two, absolute and gauge pressure. So what are those pressure, class? What is absolute? What do you know about absolute? And what's the difference between the absolute and the gauge pressure? Anyone? Based on the definition here, pressure measured relative to absolute zero pressure. However, for the gauge pressure, it is pressure relative to the atmospheric pressure. So what it means here? Anyone would like to try? What do you think? Why we have those kind of pressure? What the difference? Any idea so far? Okay, if you don't have any idea, let me show you the difference between those pressure. Let's see, we have the diagram here. Okay, this y-axis refer to pressure. Okay, only y. And this definitely refer to zero, right? And of course, we name here as absolute. Zero. What do you know? Do you still remember, everyone? Absolute zero. What is mean by absolute zero? Do you learn about our previously temperature? What do you mean by absolute zero?
Literally zero.
So like the bare
Pardon?
minimum
Pardon?
isn't absolute zero like the bare minimum. Like for example in Kelvin, zero is negative 20 217 270.
Okay, good. Okay, good. That is a value. Good. In the Kelvin, we consider negative 273.15 as the absolute zero. So what it means in terms of particle, the molecular? What
No.
happened to the particle?
No kinetic energy.
Temperature will
Moving.
It is not moving. Okay, it is static. The particle around us, the particle in the fluid, static, not moving. So it considered as absolute zero. Okay, so we are living in the, okay, our body now living in the atmosphere. Okay, we know already we are living in the atmosphere. Our body full, our earth, okay, surrounded with atmosphere. Alright, so since our body filled up with the atmosphere, okay, we are basically surrounded. Okay, we are surrounding with the atmosphere. So let's take a look about this. Okay, let's say what is the value of atmospheric pressure? Okay, let's say, okay, the value of atmospheric pressure is, anyone knows? 101.325 kilopascal. So it is positive, right? Positive value. So let's say this is the value. Okay, 101.325 kilopascal as our PATM. Okay, so our atmospheric pressure measured is 101.325 kilopascal. Okay, so what it means here, you can see, for example, the gauge pressure. The gauge pressure is a pressure measured relative to the atmospheric pressure. That means relative is the point of reference. Okay, the point of reference is atmospheric pressure. So from here, our point of reference is the atmospheric pressure here. Okay, this is our point of reference for gauge. Alright, for example, if we have this pressure. So what is the gauge pressure? The gauge pressure basically, from here, our measurement start from 0 to here. This is P gauge. You can see pressure relative to ATM, PATM. So now the ATM become the reference pressure. So that means it is reference, the value is 0. Okay. However, for the absolute pressure, you can see here, relative to absolute zero pressure. Where is absolute zero? This one. Okay. So this is now become the reference for the absolute pressure. If we have this pressure, how to calculate this pressure at X? Definitely from here to the top. Okay. So now here is the P absolute. Because P absolute, remember, the reference from the absolute zero. Okay. While for the gauge pressure, remember, it is relative to the atmospheric pressure. So now if I want to calculate the pressure, let's say pressure at X, okay, in terms of absolute, what should I do? Okay, in order to calculate absolute pressure at X, so pressure absolute here, okay, sorry. How to calculate pressure at X? Absolute one. Definitely ATM, PATM. You can see here, this is PATM, right? PATM plus with P gauge. Then you will get the P absolute X. All right. Okay. What happen if we have the pressure from here? Let's see text. Okay, if we have this pressure, this is pressure Y. Sorry, this is at point Y. Okay, you can see in order to get the pressure at Y, this is P gauge. P gauge Y. Alright, so can you see that P gauge of Y is basically a negative. Alright, it is a negative negative gauge pressure. So, in other words, we can say that P gauge of Y basically is a vacuum pressure. Alright. So, anything after this, when the pressure below the atmospheric pressure, we consider as a vacuum. All right. So far, everyone understand? Clear about this?
Yes, sir.
Okay, I got a question for you. What do you consider when the pressure consider perfect vacuum? Perfect vacuum.
Absolute zero.
Yes, definitely. Absolute zero. It is perfectly vacuum. So that means it is reaching to the absolute zero. Alright, understand, yeah? Okay, good. Now, let's take a look for the pressure at the point. Okay, this is a very important. I need your focus on this. Okay. So, pressure at the point, since this is a static, there is no motion at all. Let me draw you a beaker. And then we have the fluid particle. Since there is no motion at all, okay, only the force, only the pressure normal to the force exists. No shearing stress, okay? Only this one, all right? Perpendicular. So, pressure at any point in the fluid at rest is the same in every direction, all right? So that means when you look at here, I want to draw again, yeah? It is in the same direction, magnitude. That means this value maybe 1 Newton, this value 1 Newton, this value 1 Newton, this value 1 Newton. Alright? The value of force in every direction is the same. Okay, that is what it means. Consider a random wedge shape. Okay, so now I would like to consider a random wedge shape. For example, this is the random one. Okay, let's say this is the wedge. Alright. Definitely the wedge will have the angle theta. Okay, and then let's put the axis here. This refer to the Z. This refer to the Y. Sorry, this refer to the X. And then this wedge is 3D. Consider a 3D. Okay. And then we have the this one behind it. It's hard to see, but okay. Alright, I hope you can imagine, yeah. Let's say we need to specify the, okay, from here, the distance from here to here, let's say this is delta Z. The distance from here to here, delta X. The distance from here to here is delta S. That means slanting, alright? And, okay, we have the distance here to here is delta Y. Okay, that means this is to the Y. Alright. Okay lah. So, let's assign when this weight shape element inside the water, inside a water, let's say inside a beaker, what do you think the force will exert on this element? What do you think the force? Remember, we have the normal force, right? We should have the normal force. So, let's apply the normal force. Use the color here. Okay. The normal force should be perpendicular. Okay. So that means we have the normal force here. Alright. So here we call as a normal force P, pressure. Which direction? Pressure in which direction? Z direction, X or Y direction? Class? What do you think the pressure at the bottom?
What? Z
Z
direction.
direction.
Z direction. This will have the normal force, which is pressure from X direction. Any other force? Should be perpendicular.
S.
Yes. Should be perpendicular, right? So we have P normal. All right. Any other force? One more. We have one more force. Pardon?
Why direction?
Weight.
Yes. Perfect. Shafiq. Weight of this element. All right. So since we have the weight, let's derive the weight. Weight equal to mass multiplied with gravity, right? So what is the mass of this element? So mass equal to rho multiplied with volume. Okay.
Doctor,
Yes.
why there is no force along the Y?
Which one, yeah?
Why there is no pressure along the Y?
Along the Y. Okay. Consider, wait, yeah. Okay. X, Y. Okay, consider this is 2D. Okay. Okay. Because we want to show you the 2D. If it is 3D, that means it is a lots of derivations lah. Okay. So this is okay, good. This is for 2D. But I draw in the 3D because we need the surface area. Remember? Alright. So mass is equal to density multiplied with volume. So from here density, let's say we know the density of this element. How about the volume? What is the volume of this element? Volume of this element is half
Delta X and delta Z and
delta X, delta Z, and delta
S.
delta S or delta Y?
Y.
What?
Delta
S
Y.
and Y.
Because this is half of the cubic, right? Half of the rectangular. So delta X, delta Y, delta Z. Okay, perfect. And then we can substitute here. The weight is equal to rho G. Okay, rho G, and here the mass. Sorry, I try to. Okay, mass is equal to rho, and V is 1/2 delta X, delta Z, delta Y multiplied with G. Okay, we simplify half rho G, delta X, delta Y, delta Z. Okay, that's it. Another one. Okay, after that, no motion, that means no acceleration. So we can say here, summation of force, whatever direction X or Y, equal to 0. Okay, so let's derive the summation of force in the X direction equal to 0. So what's the force involved in the X direction? Remember our formula, the pressure is equal to force over area. In order to get the force, pressure multiply with area. So what's the force in X direction? Definitely P Okay, put this way, yeah. Positive to the right, negative to the left. Okay, so pressure in the x direction here must multiply with the area here. Okay, is it clear? So what is the area here? Anyone? What is the area? Delta
Z, delta Y.
delta z, sorry, delta z and delta y. Okay, we have another force. Yes, you can see pressure normal. We can do the x direction. So this is P and X, and this is P. Sorry. Okay, this is P and Z. All right. So this angle theta belongs to where? Here, here, or here? 1 or 2? Do you still remember? The angle theta here belong to who?
Below part.
Okay, good, perfect. Below part theta. All right. So from here, okay, we have the P. Okay, this P and X is negative to the left. So minus lah. Minus pressure of normal. Okay, it is sine or cos? It is sine. Okay. Sine theta multiply with the area. What is the area? Area. Multiply of what?
Delta S, delta Y.
Yes, perfect. Delta S, delta Y. I hope I hope all of you knows, yeah? The area must be perpendicular here. All this. All right. And then, do we have any other force? I think no, equal to 0. Okay. From here, I want to eliminate sine theta. I don't want to have sine theta. How do I remove sine theta? Okay, based on this correlation. Okay, in order to get delta x, so what should I do? Delta S, sorry. Okay, in order to get delta Z, okay. Okay, here, in order to get this delta Z, I should use the hypotenuse. Okay, delta S sine theta, right? Okay, so from here, can I substitute into equation 1? Okay, from this equation, equation 2, I want to substitute into equation 1. Alright, so I try to substitute Px delta z delta y minus Pn. You can see sine theta delta s is the same here. So I just replace delta z delta y equal to 0. So now you can see we have the similarity. So that means we can cancel out delta z, delta y. And finally, P x is equal to Pn. So what can you deduce from here, class? The pressure in the horizontal direction is equal to
0.
Equal to Pn. You can see here.
Same.
So whatever force, let's say lah, let's say we have the force here. This is horizontal, right? So this is the same, Pn. So from here, we can say that the pressure in the horizontal direction is the same. Not change at all. For example, this is X, he refer to 1 Pascal. This is 1 Pascal, 1 Pascal, 1 Pascal. No change because we only have one single unit. Okay, clear yeah about this? Okay, any question before we proceed on the next force in Y direction? Sorry, force in Z direction. I think okay yeah. We proceed on the Z direction. Let's proceed on the force. The summation of force in the Z direction equal to 0. Okay, positive upward. Okay, we have force Pz. So Pz positive multiply with the area which is delta. Okay. Delta Y and delta X. Okay. And then we have the force from the normal, which is minus, facing downward this one, yeah? Okay. So Pn cos theta delta S delta Y. And then minus the weight. Okay. So from here, I want to directly put the weight here.
Doktor.
Yes.
Sorry, for the Px equal to Pn2, dia Px equal to Pn or Pnx
Which one eh?
Yang the first equation tu kan Px equal to Pn kan, dia Pn ke Pnx?
Px ya.
Px equal to Pnx or Px equal to Pnx?
Okay, X tu subscript kecil.
Oh.
N tu subscript. Very
Oh.
small.
Oh.
So that means the X to refer to direction.
PNX.
So P in X direction, that means the pressure in the horizontal.
Oh,
Kalau PZ refer to like this or this one.
okay. So Pnx
Okay.
lah sebenarnya. Okay, faham.
Okay, betul. Yes, P and X. Okay. For here, you can see this is pressure. Who's belong for this pressure? N. Which direction? X. Okay. Clear?
Alright, ni clear doktor.
Okay. Okay, and then minus weight. So what is weight? This is one we derive, which is half rho G delta X delta Y delta Z. So half rho G delta X delta Y delta Z. So now equal to 0. So what should I do to eliminate cos here? I don't want cos. How to eliminate cos theta delta S? So again, let's say this is equation 3. Alright. So again, in order to get delta X is equal to, okay, delta S hypotenuse cos theta. So from here, let's say this is equation 4. Substitute into equation 3. Okay, you can see here, I can replace directly with delta X. So, write again, Pz delta Y delta X minus Pn delta X delta Y minus half rho G delta X delta Y delta Z equal to 0. And we can simplify delta Y delta X. Okay, what do we have now? We have P Z minus Pn minus half rho G delta Z equal to 0. So I want to make Pz ni as a subject. So Pn plus half rho G delta Z. So that is the final one lah. So what is your reasoning from here? the pressure in the vertical direction, what happened? Is there any change, class? Is it the same with the pressure in the horizontal?
No,
Okay, why no?
depends on the depth. Change of
Yes,
pressure.
perfect. You can see where's the equation of depth. Where's the parameter of depth here? From
Delta
the
Z.
equation. Delta Z. Delta Z is the depth. Another one, what can we control the pressure vary because of the delta Z and also one more thing. Density. Can we control the gravity?
No.
No, because gravity is constant. Okay. Pn also can be constant. Alright. The one that vary depends on density of the water. Maybe we do at the salt, at the sea, at the river, at the normal water. The pressure will be different at different depth. Okay. So this is what it means lah. Okay. So that means what can we deduce here? Okay. The most important remark. The pressure in x direction is the same. Okay. Horizontal pressure, no change. While the PZ pressure, okay, vertical pressure vary with depth, which is delta Z and density. Okay, that's it. Very simple, right? Okay, we take a break lah. 2 minutes. Boleh tak?
Okay.
Alright.
Doktor. Doktor.
Okay, let's proceed on the next lecture. So now we proceed on the variation of pressure with depth. Since we know that the pressure in the vertical direction change with density and depth delta Z. So now we go further in detail. So pressure in hydrostatic fluid doesn't change in horizontal and change in vertical direction. Pressure increases in vertical direction because of two things. More fluid rests on deeper layer and extra weight is balanced by increasing in pressure. So let's say this is the pool. Okay, let's say this is a pool. And then this is you swimming at the bottom. And when we feel the water here, okay, we feel the first stage of water. What do you feel? What do you experience? Maybe you are not experience hard lah. Okay, when you measure using the device, the pressure here, for example, at this here, okay, maybe 100, 10 Pascal, for example. Okay. After that, you fill up with the another fluid. Suddenly, right, you measure the device at X here, the pressure become, what do you think? It is more or less? Of course lah, more, right? So the pressure become 20 Pascal. So the more you fill the water, the pressure keep increasing. Because of why? Because of, you can see, more fluid rests on the deeper layer. Okay. And extra weight is balanced by increasing pressure. So that means because of the deeper layer, you will have the extra weight. Okay. So from here, let's get the variation of pressure with that equation. Okay. Let's take a look with the rectangular fluid element. Okay. Now we try to use the rectangular fluid element. The previous one, we use the weight shape element. For this case, in order to investigate the variation of pressure with that, we use the rectangular shape. Okay, let's say this is the shape. Okay, I try to draw nicely. And then what happened to this shape? Definitely it will have the pressure, normal, yeah, not tangential, normal pressure. So let's say we have the pressure here. The pressure means keep increasing. Okay, this is pressure. And this magnitude, the same here magnitude. Okay, here the same, yeah. Right. And then one more and one more. Okay. What do you think of the pressure on the left side? Should be identical, right? Okay, should be identical. Okay, what do you think of the pressure at the top side? Should be identical to this one. Alright. This is basically the pressure profile for this case. Okay. And then we need to specify the axis. Okay. For is our calculation later on. Let's say this is this is Z and this is X. Okay. And then the distance here from here is Z1 and Z2. And here, of course, X1 and X2, the location. So from X1, X2, we called as a delta X. From Z1 to Z2 is a delta Z. And of course, we have the wick, which is from the centroid to the bottom, which is wick. Okay. This is the same thing again. Okay. What do you think of the force in the horizontal? Do you think it will change in the horizontal direction? No, right? The force in the horizontal direction will never change. It is identical. All right. For example, the force in here will be the same in here. The force in here will be same in here. It is identical to each other. Don't worry. The one that we should worry is the vertical one. All right. So from here, let's derive, okay, the summation of force in Z direction equal to 0. Because the force in the X direction won't change. So just ignore the force in the X direction. Okay, it is cancel each other. Okay. What is the force in the Z direction? Of course, we have, okay, let's say this is P1 and this is P2. Okay, so pressure 1 multiply with the area. What do you think of the area? Anyone would like to try? What is the area of P1?
Delta X, delta Y.
Yes, perfect. Even though I never show you delta Y, but you already know, yeah? Why? Okay, delta X, delta Y. And then we have P2. The same thing, delta X, delta Y. And then we have the wick equal to 0. So the problem here, we never derive the wick. So let's derive the wick. So wick here equal to mass gravity. We know that mass is equal to rho v. So what is the volume? The volume of this is delta X, delta Y, delta Z. Because this is rectangular shape, yeah. The previous one is a triangular. So the weight here is mass is a rho, volume delta X, delta Y, delta Z, gravity. Okay, so I want to substitute in here. So just remove here again. Put this one. The weight is equal to delta rho G delta X delta Y delta Z equal to 0. Okay, can we cancel? Yes, definitely we can simplify. Delta X, delta Y. Okay, finally, what do we have? Py minus P2 minus rho G delta Z equal to 1. It is almost the same, right? Like this one. Okay, almost the same, but the shape is different. Okay. So from here, I want to rearrange. Okay. So from here, I want to make sure that okay, P2 become the first one. I want to rearrange lah. P2 minus P1. Okay, equal to P2 here. Okay, equal to negative rho G delta Z. Alright. So P2 minus P1, we can simply put the change in pressure is equal to negative rho G delta Z. Alright, we know that the gamma here is rho multiplied with gravity, right? So delta P is equal to negative gamma delta Z. Okay, so from here, you can see that the change in pressure toward the vertical direction, from the top to the bottom, it is negative value. Alright, the pressure is a negative value. Okay, from the top to the bottom. Okay. Alright. So we can also finally write this equation. Okay. So we can also write this equation. Delta P is equal to integration negative 1 to rho G dz. Okay. So a negative sign here. Okay, I would like to give a remark. Negative signs mean, okay, indicates pressure. Okay, in static fluid. Increases, okay, linearly with depth. Okay, that means the negative is just the direction. Okay, the direction towards the top to the bottom, and it is increases linearly with depth. Okay, you can see this is the equation. Pressure with depth. So it is linear. Y equal to mx plus c. Okay. So alright. So let's do a recap. Okay, we do the quiz time. Alright. Let me open the quiz. Please be ready, ya.
Doktor, maksud doktor yang increase linearly tu maksudnya kalau pressure increase dia punya depth pun increase macam tu.
Terbalik tu. Kalau depth tu increase, baru pressure tu akan increase.
Oh, depth increase pressure. Oh, okay.
Tapi direction tu ke bawah lah. Mesti ke bawah. Nampak tak negatif?
Cuma dia punya magnitude dia increase.
Magnitude tu increase.
Okay.
Don't confuse, symbol negative is the direction only. M3. Okay. Let's do quiz time. Okay, please go to www.menti.com and enter the code 77027781. Let's see who will be the winner. Okay. Please everyone join. We want to see your participation. Okay, we have 42 now. Waitings ada. Let me copy the link. Are you able to see the chat room here? Okay, you can click the button. You can click the link. I shared to you inside the chat box. All right, now let's proceed on the question. Okay, please be ready, class. Answer fast to get more points. Gauge pressure is what? Okay. Okay, 7, 5, 4, 3, 2, 1. So what's the answer? Okay, majority of you got right. So it is relative to atmospheric pressure. Okay. Who will be the highest scoreboard? Okay, good. Yani the faster one. Second hard storm. Kambing, XY, yo. Daniel, the last. Okay, the top 10. Okay, good. Okay, be ready. Absolute pressure is? Absolute pressure is what? Okay, this is equation. Okay, it is ATM plus gauge pressure. Okay, good. Alright. Okay. Who is the fastest and the top one? Okay, XY. Good. Okay, Yani. Number. Okay, number 6. Okay. Tiger, Baby and Moon. Okay, Moon. Appear to be the top 10. Good. Question 3. Answer fast to get more point. Horizontal pressure is what, yeah? You still remember? Okay, I hope you got all right, yeah? Oh, okay, please read. Horizontal pressure must be the same in horizontal direction. Okay, not proportional in any horizontal direction. That means increasing the horizontal x value, it will increase the pressure. No, it will be the same. Okay, let's see who is the. Okay. Okay, yo. Number 1, the faster Hafizi. Good job. Shafiq. Okay. The second last question. Answer fast to get more point. Vertical pressure is what? I am sure. Please choose carefully, yeah. Okay. Okay. Change proportional to density and depth. Alright. Okay, for this part, you need to make sure we have derived before. Pressure in the y direction or z direction equal to Pn plus half rho g delta z. Final, let's see the scoreboard, leaderboard. Okay, good. The faster Lee BQ and then Apex Legend. Okay, good. Excellent. Android. Finally, please determine the winner. Answer fast to get more point. Pressure increase in vertical direction because of what? Okay. Let's see. Time's up. You got to answer, yeah. Fluid rest on deeper layer, correct. Second one, effect of extra weight. Finally, who is the winner? Okay, congratulations, legend. Okay, legend, please introduce yourself and as usual, your strategy, please. Legend, what's your name? Introduce yourself.
My name is Muhammad Shafiq.
Oh, Shafiq. Okay, good Shafiq. You are from section?
Section 16.
Okay, section 16. Your strategy, please.
My strategy is study before class.
Okay, this is good. Okay, congratulations, yeah. Shafiq, please uh, give me your full name. Just spell it. Your full name.
Muhammad.
Wait, yeah. Okay. Winner. M-O.
M-U.
M-U.
H-A-M-A-D.
M-A-D.
S-Y-A-F-I-Q.
Okay, Shafiq. Okay, Bin.
Bin Muhammad Taufik.
Okay.
M-U-H-M-A-D. Alright.
Okay, it's okay. I will find section 16.
Yes.
Okay, congratulations again, Shafiq. Well done. And keep up the good work. After this, I hope all of you lah, please study before the class if you want to get extra point. Okay, this will be the extra mark for you during the coursework lah. Okay, for your coursework. Okay, good. Okay. Now you have go through about the class. Okay. Let's have break lah. 5 minute break class. After that, we continue on the second lecture, which is this one lah. This one. In the meantime, you can study the measurement of pressure, barometer, manometer, okay, and then you can scan your attendance. I share you the attendance. Okay, class. I will share to you in the WhatsApp the lecture note. Alright, in the WhatsApp, yeah. Please look at the WhatsApp because I haven't post in the e-learning. Wait, yeah. Okay. I have post the lecture note week 3 for student. Yeah. Okay. Okay, so let's continue our next lesson, which is measurement of pressure. The last class, the last session, the last lecture, we learned about the parameter of pressure, which is the gauge pressure, absolute pressure, all right? And then we learned about hydrostatic, right? How to derive the hydrostatic, the pressure variation with that, which is P, delta P equal to negative rho G delta Z. So now we proceed on the measurement of pressure. That means we need a device to measure the pressure. Remember that it is difficult for us to measure the pressure by sensing. Okay. So we need a device that can measure the pressure accurately. So what is the device? Okay, the first device is barometer. Okay, we call as a barometer. Why it is barometer? You can see this is bar. Bar refer to the unit of pressure. Okay, we have Pascal, we have pound per square inch, we have also bar. Alright. So 1 bar is equivalent to 10 to the power of 5 Pascal. Okay, this is what you need to know lah. Barometer measure the absolute pressure of atmosphere. That means this device, barometer, measure the atmospheric pressure in terms of absolute. So what is absolute? It is relative to the atmosphere. It is relative to the absolute zero. So how does a mercury barometer work? So for this case, the barometer consider the mercury. We are using the mercury. So the first step to do the measurement is a very simple. You need a beaker and then you need a tube. Okay, the beaker filled with mercury. Right? Let me draw to you nicely. This is like this. Okay. All right. Okay, first we fill up with the mercury. Okay, we fill up with mercury. This is the mercury. All right. Let's say the mercury color should be this one lah. Okay, the standard mercury color. All right. The first beaker we fill with mercury. And then the next one, we have the tube. We fill with mercury as well. Okay, this is the tube. I fill with mercury until this section. And then I try to invert inside here. Inverted. So what happened? All this become like this. Okay. So this part filled with mercury. Okay, I hope you can see. Alright, so this is how the process lah. Alright, so from here you can see that this mercury is exposed to the atmospheric pressure. So 101.325 kilopascal. So from here it is exposed to the PATM. Okay, so remember that the pressure will exert to the surface. So let's say this is PATM. We have PATM surrounding this device. Okay, so definitely we have the pressure. What do you think of the, okay, we have the pressure here. We consider as P1. This is considered as P2. Alright, and this height we refer to H, height of mercury. So from what we have learned previously, okay, remember that our hydrostatic equation, okay, this is our hydrostatic equation, yeah. P2 minus P1 equal to negative rho G, okay, rho G Z, okay, delta Z. This is named as hydrostatic equation. Hydrostatic equation. Okay, so P2. P2 refer to P atmosphere, right? So we can say P ATM minus P1. So what do you think of P1? What is the value of P1? Okay, this is mercury. Do you think the mercury will evaporate?
No,
No. Why no? Why not evaporate?
because have high melting point.
Okay, basically, the nature of the mercury, it is hard to evaporate because the strong bond between the mercury molecule. So even though you heat the mercury, it is not evaporate. That is why you can see thermometer using what? What thermometer? You can see the thermometer device using what liquid? Mercury, right? Because when you put the thermometer inside the hot beaker, what do you think of the mercury? The mercury become gas? Become gas, simply become gas? No, right? That is why they use the mercury, because mercury will hard, okay? Never ever evaporate. Okay, that will disturb the reading. For example, the thermometer using the water. And then you put the thermometer inside the hot water. What do you think? It will become the gas, right? So do you think you manage to read the data? You can read the level, class, when the
No,
water
doctor.
become gas? No, right? So the mercury, when you heat the mercury, it will expand. That's it, without evaporate. So that is the specialty of mercury. That is why we are using the mercury in the barometer. Okay, so when there is no particle or evaporation here, okay, let's say there is no particle. What do you think of pressure exerted at P1? Equal to 0, right? So 0. Negative rho of mercury, gravity, delta Z is H. So PATM equal to, okay, PATM here, Okay, let's say. Okay, sorry. This H, okay, I want to highlight again. This is Z1, okay, and this is Z2 because this is at point 2. So delta Z is refer to Z2 minus Z1. Okay, you can see here. Okay, this one is basically Z2 minus Z1. How do we know 2 minus 1, not 1 minus 2? We refer here. Okay, when this is 2, this is 2. 1 and 1. So, PATM equal to negative rho of mercury gravity Z2. Where's the Z2? Z2 is here. Okay, let's say this is our point of reference. We need to identify our reference line. Okay, when it is reference line, become 0. So Z1, Z2 equal 0 minus Z1, which is H. So negative, negative cancel, become PATM equal to rho mercury gravity H. That's it. Very simple, right? Okay, let's try example. I think this is quite easy. Find atmospheric pressure. You can see here. Right, I highlight the question. Find PATM. So the question asks, what is PATM basically? So based on our derived, PATM is equal to rho of mercury. When it is mercury, you can see Hg. Hg refer to mercury. P of mercury, you can say Hg. Gravity and height. So what is height? This is height. But this height in terms of millimeter. Okay, this is metric. All right, this is the SI unit. Do you think this is SI unit? Millimeter?
No.
No. So what is the actual SI unit? Should be?
Meter.
Okay, meter 0.74 meter Hg. So just substitute. Okay, just substitute the density. Okay, the density of the mercury. I believe it is given. Okay, don't worry. 13570 kilogram per meter cubic. Okay, just substitute the value only. Okay, for this case, you are not necessary lah to substitute the unit. Okay, if you can substitute the unit, it's better. Okay, for simplicity, just substitute the value only. 13570 multiply with 9.81 multiply with height 0.74. So the final should have a unit. Okay, the answer is 98.5 kilopascal. Okay, should have a pascal, yeah, the final unit. Okay, this is quite easy. Any questions so far? For example 1, is it clear or you have a question? Shafiq, Shihab, Adriana.
No, doctor. Good.
Okay, clear ya class? Okay. Okay, very good. So this is sea level atmospheric pressure. Okay, remember that our Earth's contain the Earth's, alright. Our Earth's have the sea level. Okay, that means we are surrounding with the atmospheric pressure. So how do we set the reference line? So the reference line basically set from the sea level. So when you look at the sea level, you see sea, it is considered as 0. All right, that means it is under reference. It is considered as a reference line because the C is no shape, right? It is the minimum shape. Okay. For example, this is our Earth. Okay, and then we have a mountain. We have the whatever lah mountain here. Okay, we have a mountain. And then we have the sea. Okay, let's say this is the sea. Okay, this is the sea. This is the sea. Do you think which point appropriate for you to put as a reference point? Do you think this is appropriate? Okay, if you put the reference line at the mountain, what do you think at the next mountain? Is it the same? Reference line? No.
No.
Okay. Because, for example, we are measure from the center of Earth. Okay, this distance, this distance, this distance, this distance, the same, right? This is radius. So that is why we consider the C is our reference line. This is the symbol. Okay. So the value of the pressure at the reference line basically 14.696 psia. Okay, you can see pound per square inch absolute. It is measure absolute. Okay, this is in terms of imperial. This is in terms of metric. This is in terms of the length. All right, the length of mercury in inch. This is in terms of matrix length. So now let's proceed on manometer. So what is basically manometer? Yeah, manometer is basically the U-tube shape. Okay. So let's recap our hydrostatic equation. Our hydrostatic equation basically, okay, P2 minus P1 equal to negative rho G H, you don't put H lah, put Z. Z2 minus Z1. Should be the same, yeah? 2, 2. If this is A, should be A. Okay, B, if this is B, this is B. Alright. So this imply height of the fluid volume, fluid column can be used to measure the pressure difference. So that means this equation will be used for pressure measurement inside the manometer tube. Okay, so manometer consists of a glass and plastic U-tube. One or more fluid like mercury, water, alcohol, oil can be inside the manometer. So what's the how the manometer looks like? This is how it looks like. We have the pressure. Okay, this is maybe the pressure, yeah, pressure at A. And then we have the manometer. This is manometer, only manometer. Okay. Okay. Alright. That means this manometer exposed to the P ATM. Alright. And then you can fill this manometer with first mercury. Okay, maybe this is mercury. And then you can fill with oil. Maybe this is oil. Maybe you can fill with water. Of course lah, water at the bottom. Maybe other than oil lah. Okay. Maybe you can fill with something else here. Okay, liquid X. Okay. So this is what we call a manometer. Manometer only one flow from here to here. Okay, this is what we call a manometer. Okay, so let's consider the column of fluid. Okay, from here you can see that we have the column. We have full of column here. Okay. let's consider as a straight column. Alright. Inside this column, we have several fluid. Okay, first we fill up with fluid 1. Okay, second fluid, next fluid, and final fluid. Okay, so here let's say this is liquid A, liquid B, liquid C, liquid D. And then this is point 1. This is pressure at 1. Okay, exerted here, yeah. Pressure exerted here, P1, P2, P3, P4, and P5. Okay. And then definitely 1 refer to Z1. And so on. Okay. So the question normally will ask, what is the difference of pressure between P1 to P5 or P5 to P1? So that means P5 minus P1. So from here, simply we can add or we can do the summation of total pressure. Pressure 1 plus pressure 2, pressure 3, pressure 4, and pressure 5. So we need to sum up all the pressure. Okay, so how to sum up all the pressure? Is it simply just sum up all the pressure? No, we have the method. Okay, we are going to use the hydrostatic equation. Okay, for this case, I want you to focus carefully. This is a very important. Okay, remember our hydrostatic, which is P2 minus P1. Negative rho G delta Z minus Z, Z2 minus Z1. Alright. So from here, let's put the first step to solve this. We need to set the reference line. Okay. Let's say I want to put the reference line here. Okay, this is our reference line at P5. So again, using hydrostatic equation, which is P2 minus P1 equal to negative rho G Z2 minus Z1. Okay, we start from top to the bottom, our flow like this. Okay, so P1 going to P2. That means P2 must minus P1 equal to negative rho of liquid A, gravity, Z2, of course this is Z2 minus Z1 plus, okay, P2 go to P3. That means P3 minus P2 equal to negative rho of B, G, Z3 minus Z2. And plus P3 go to P4 plus P4 minus P3. Negative rho C, G, Z4 minus Z3. And finally, plus P4 go to P5. So P5 minus P4 equal to negative rho D, G, Z5 minus Z4. Okay, total up. You plus everything. Okay, you can see P2 minus P2. What do you think? Cancel 0, right? So cancel. P3, negative P3, cancel. And P4 minus P4, cancel. What do we have finally? We have P5 plus P5 minus P1 equal to, okay, combination of all this, you need to plus. You need to plus all this, yeah? Plus. So negative G, let's factorize negative G outside and put the row A. Okay, Z2 minus Z1 plus, since we factorize here, this become plus. Okay. Rho B Z3 minus Z2 plus rho C Z4 minus Z3 plus rho D Z5 minus Z4. Close bracket. So that is the equation of hydrostatic applied to this pressure at the column. Alright. So far, any question? Any question pertaining to the step? Any unclear? Any doubt?
No, doctor.
Okay.
No, doctor, no.
Okay, good. Okay, this is just theory. Let's apply. Okay, for the case of manometer. Okay, this is fine. Okay, let's say we have the real manometer here. Let me draw for you. Let's say this is manometer. This is at point A. Okay, let's draw nicely here. Okay. Okay. This manometer, as you can see, exposed to the PATM. And then this is gas A. And then we fill up with the liquid. I don't know lah, maybe liquid, what kind of liquid. Okay, it will be like this, right? This is the liquid.
Tak ada. Asal? Asal? Asal?
Okay. Okay. So from here, let's label. This is considered P pressure at point A. No. Pressure at point A. Okay. And the first step you need to do this. Remember, the first step to solve this question, you need to set the reference line. Let's say I put this as a reference line. Okay, any kind of measurement we reflect to the reference line. Okay, so from here, let's say this is point. This is Z1. This is okay. This is point 1. Okay. Okay, so now I want to show you step by step on how to solve this question. Very simple. Okay, the first step, remember that set the reference line. After that, make a direction of your calculation. I want to calculate from here, from left, here until here. This is my direction. Okay, the first part, let's put here. This is point 1. Okay, this is point 1. Okay, so from PA to 1, definitely we have pressure at 1. So what you need to do? So PA go to P1. That means P1 minus PA. Alright, equal to negative rho. Okay, rho of what? Rho of A, gas A, G, Z1 minus ZA. Okay, plus 1. Okay, you can see here, this level, this one level is the same level here, right? Okay, let's say this is point 2. What do you think of pressure 1 and pressure 2? Is it same or different? Pardon? It is the same because we have the same depth. Okay, same level. So now let's jump from 1 go to 2. So these 2 go to 3. So 2 go to 3. So that means P3, use the red color, P3 minus P2 equal to negative rho. Maybe this is liquid rho B lah. Okay. Z3 minus Z2. And then, alright. So we know that P1 is equal to P2. So P1 can cancel with P2. And P3, what do you think of P3? Is it equal to PATM? Pressure exert on the surface 3. Is it
Yes.
considered P? Yes. So can we replace P3 with PATM? Yes. Okay. So PATM minus pressure at A equal to negative. Okay, you can factorize lah. Negative G rho of A Z1 minus ZA. Okay, what do you think of ZA? What is the value of ZA?
0.
0. We can cancel. Minus 0. Okay, plus rho B Z3 minus Z2. Okay, that is the equation and how you apply to the manometer. Okay, since you know this one, okay, it is best for us to substitute the value. Alright, this is the real case, okay? The real case for you to go through this example. Okay, let's say a closed tank contain air and oil. A tube manometer containing mercury, okay, is connected to the tank. Column height are H1, H2, H3. Find pressure reading engaged in PSI, which means pound per square inch. So the first step, let me draw you the tank, the closed tank. Okay, we have the tank. The tank is sealed, yeah, closed. And then attached to the manometer. Alright. Okay. This manometer open to the atmospheric pressure. However, inside the tank, we have two fluid, which is air and oil. Okay, let's say this is oil. Okay, oil. Okay, oil nanti this section lah. Okay, let's say this is oil. And then we have mercury. Okay, maybe this is mercury level of mercury. Okay, let's say this is mercury. Okay. This is mercury. All right. So remember the first step, what we need to do. We need to set what? If you still remember lah.
Reference line. Point.
Reference line or reference point. Okay, reference line. So from here, let's put here, from here. Okay, from here level. Maybe from here lah. It's okay. From here. Okay. This is H1, which is 36 inch. Okay, you can see this double too. Double quotation mark is inch. A single quotation mark is foot. Yeah. From here to here is H2, 6 inch. Alright, from here it is given
Doktor tahu the
Okay,
location.
basically this is given lah.
Oh, ada gambar patutnya.
Betul. Okay, from here to here. H3. 9-inch. Okay. So the first step, we need to set the reference line. So where's our reference line? My advice to you, set here. Okay, why? Because this reference line connected to H3 as well as H1 and H2. Okay, very simple, yeah. If you put here suddenly the reference line, how to get this value? It is very difficult, right? So choose the one that connected to each other. Okay. So to solve this one, quite simple. Let me give you, this is Hg. Okay, Hg given with as gravity, specific gravity of Mercury is 13.6, and oil on the other hand is 0.9. Okay. Okay. So after we set the reference line, we need to have the direction of our calculation. Let's say we start from here and finish here. Okay. So the first step, okay, let's say this is P of X. Okay. So this is 0.1. Okay. And this is 0.2. And this is 0.3. So from A, go to 0.1. So that means P1 minus PA equal to negative rho of oil, because we are dealing with oil. Okay, rho of oil. Okay, gravity. And then Z1 minus ZA. Alright, and then plus with 1 go to 2, we can jump. Okay, 1 and 2 the same. We can jump from 0.1 to 0.2. So now 2 go to 3. So P3 minus P2 equal to negative rho of Mercury Z3 minus Z2. Alright. Okay. So from here, we can do the calculation. Okay. How to get the density of mercury and density of oil? Do you still remember our basic parameter we learned during the last class? Using the specific gravity. What is the formula of specific gravity?
Rho
Yes, rho.
substance over rho water. Rho oil.
Yes, perfect. If this is gravity, if this is mercury, that means rho of mercury divide with rho of water. Okay. You must know the rho of water in imperial or in the English unit, which is 62.4. Yes, pound per feet cubic. This is standard. Okay, when it is not given, you must know 62.4 pound per feet cube. Alright. So P1 and P2 is the same. P1 is the same with P2. Can we cancel? Yes, P1 cancel with P2. So what do we have? P3. P3 minus PA. Alright. If you know that P3 is atmospheric pressure, you can replace P3 with ATM. Okay. Equal to negative G bracket density of oil. If we want to get density of oil, use the specific gravity of oil. Okay, let's say this is specific gravity of oil. Density of oil over density of water. And then density, in order to get density of oil, specific gravity multiply with density of water. So what is the density of oil? So specific gravity of oil is given 0.9. So 0.9 multiply with density of water, which is 62.4 multiply with Z1 minus ZA. Which is Z1? What is the value of Z1? 0, right? Z1 refer to the reference line. So 0. Okay, 0 minus with ZA. What is the value of ZA? Here, at point A here. Which is, what is the value of A?
42 inch.
Okay, perfect. 36 plus 6 divide with 12 inch. Because the the standard imperial is foot, not inch, right? So you must divide with 12 inch. Okay, refer to 1 foot. Okay, and then you need to plus lah. Continue plus. Specific gravity of mercury, which is 13.6. It is given, yeah, this one. Okay, 13.6 multiply with density of water, 62.4. And then Z3. What is Z3? Which is 9 inch. 9 minus with. Okay, you need to convert lah 9 to foots. 9 over 12 minus Z2. Z2 is reference line, which is 0. Okay, after you have calculated this, you can see that the question asks, find the pressure gauge in PSI. So this is the gauge. So what do you mean of gauge? Do you still remember the gauge? What do you think by gauge?
The measurement.
The
from
measurement
the-
refer to the measurement of pressure atmospheric. So the atmospheric become reference, right? So
Yes.
when the become reference, that means it is equal to 0. So PATM equal to 0 because this is request gauge. So from here, negative PA equal to, you calculate everything, you will get lah, negative 439.92 lb per feet square. So you convert it, you will get P of air here is equal to 439.92 pound per feet square. So the question asks how to convert from pound to PSI. This PSI is pound per square inch. So you must convert from foot here to inch. Just multiply. Okay. 1 foot over 12 inch. Okay. You can see this is squared, this is squared. Okay, cancel. And then 12 squared. So 144 lah. So 144, 439 divided with 144. So the final answer should be 3.055 PSI. Alright. That is the final answer. Okay, anyone? Are you clear about this? On this measurement so far? Class? Have any question? Basically, this is involved of the imperial lah. Involved of the imperial unit. Okay, English unit. You must know how to convert between the non-standard to standard. Okay, San Xingyi, do you have any question? Anything? Okay, I assume no question, yeah. Okay, I think I end my session now because I have a class. Okay, for your other section, fleet 1 as well. Okay, I end my session with Assalamualaikum warahmatullahi wabarakatuh. I hope that after this, please do revision like what Shafiq did before to score the leaderboard. Alright. So thank you everyone. Good luck and all the best. Assalamualaikum. Bye.
Thank you, Doctor.
Thank
Okay,
you,
welcome.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.